All right, lesson 313. Today we're going to learn about polar coordinates. Polar coordinates is our key today, and I'm going to tell you right now, you're going to like it a whole lot more than 312. If you don't like it more than 312, something's either really wrong with you or you're extremely brilliant. You love 312 because it finally challenged you. I don't know. Most people like polar coordinates quite a bit more. So let's talk about what are polar coordinates. These are going to be coordinates that have r comma theta, and that's what the next slide is going to say. But you're going to have r theta instead of your coordinates. Now, normally, what are normal coordinates? They are called rectangular coordinates. They normally are x comma y. Polar is going to be r comma theta. That's what we're going to look at today. When we switch to polar form, we get some pretty neat graphs. And that's why I say today is going to be more fun, because you're going to see some things you'll be like, ah, cool, that's neat. Especially next class when we get to the graphing, more than just the points, but the actual graphing. So let's start on a polar graph. If you look at this, there's a whole lot of details for you. Here's what I want to point out. They do not show the x and y axis. You know what they call this axis right here? Ooh, good thought. They're going to call it the polar axis. So right here, put polar axis. That was a good guess. Why do you think she said cosine? X, good, good. That is going to be called the polar axis. You know what they're going to call this up here? Theta equals pi over 2 and nothing else. That is not a y-axis anymore. That's going to be called theta equals pi over 2. Now, why would that be pi over 2? On a unit circle, that's where it'd be. That's really the only values as far as axis go. Now, check this out. You see how this has the number 3 here? Why do you think it has the number 3?
Because it's 3.
What do you mean? What's 3? Not 3 pi. It is 3. This outside circle is 3 if you count from here, which we're going to call this the pole. So draw an arrow to that. The origin is called the pole. That is the pole. By the way, all these words are telling you this. I'm just walking you through. That right there, that point is called the pole. This would be a radius of 1, a radius of 2, and finally that would be a radius of 3 out there. So that's polar axis. They put a 0 out there. What do you think that 0 is for? The theta. Yeah, don't get confused on that. That's what that's about. Okay, so if you want to look back over, I have all the words there in detail, but that's just kind of what I'm walking you through. Now, let's get started with actually graphing some polar points. So here's how this works. When you go to graph polar points, it works similar to this. The r and the theta are these two values here. Let me go ahead and just put the heading right above r theta. And what we're going to do is we're going to graph. I start with the angle. We're going to find the angle that would represent 3 pi over 4. And then we're going to go 2 circles, a radius of 2 towards that value. So what quadrant would 3 pi over 4 be in? Second quadrant. And by the way, 3 pi over 4 would be in between. It doesn't have a line here. So put 3 pi over 4 in between these two gray lines in the second quadrant. That's 3 pi over 4. And you know what? Maybe I could add a dotted line. I won't do it though. And now we need to go 2 circles out. So go 1 circle, 2 circle, put a point right there. That would represent, let me get color coordinated here. This would represent right there, point P. Now wait, why does that point P? Because count the circles. What circle is it on? It's on the second circle there. And it has an angle of 3 pi over 4 radians. Okay, let's try B. Yeah, part B is the letter Q. Maybe I should just name this PQRS and drop the ABCD. Okay, let's plot Q. Q says -1 at pi over 3. Let's first figure out where is pi over 3. First part. Now, is it this gray line or this gray line? The one that's a little bit low, the top one. Very good. This is pi over 3. Remember on your hand trick, it goes pi over 2, pi over 3. What comes in between? Pi over 4. This would be pi over 6. Good. You remember to skip. And that's referring to 0 right there. Okay. We're going to pi over 3. Now, if you have a negative, let me do this in blue. I'll switch this over to blue. If you have a negative, what that means is you don't go towards that angle. You go away from it. So here's where polar is different than like x and y. With x and y, you're thinking if it was the x value, you would think go left 1. or go right one. But with polar, it's different. It's either you go towards the angle or you go away from the angle. We're gonna go one circle away from pi over 3. So this point is gonna be right here. Notice how it's still in this line? It's still in this diagonal line that theta equals pi over 3. That would be point Q right there. All right, let's try R. Do R in green. Negative 30 degrees. So what does it mean if you have a negative degree? Instead of going against the clock, counterclockwise, you go with the clock, clockwise. Okay, so how much would be 30? It's kind of like pi over 6, but going down. This is the same thing as negative 30 right here. That's negative 30 degrees because this would be negative 90 degrees. It's in thirds. And this says 3. What does the 3 mean?
The outer circle.
We go towards it, the third circle. So it'd be this point right there. That would be the point for R. Now the last one, -1, negative 7 pi over 6. I want you to think of, if this were a positive 7 pi over 6, where would that be?
Third, fourth.
7 pi over 6 is the third quadrant. If it was positive, it'd be the third quadrant. And pi over 6, using the hand trick, which finger is the pi over 6 finger again? The ring. That's close to the x-axis. That's close to the no denominator finger. So it's the line in the third quadrant that's close to the x-axis. It's this one. If it were positive 7 pi over 6. So here's what I'm going to do. I'm going to erase something. Don't do what I'm going to do. If this were, I'm going to first graph it as if it were 7 pi over 6. If it were 7 pi over 6, remember what pi came from. It's a measurement of radiuses. It would mean you go one radius 7 pi over 6 times around, and you would get to here. Now that's what it would be if it were positive angle. You follow me? 7 pi over 6 is a distance. It's 7 pi over 6 radiuses around that circle. That's what positive 7 pi over 6 is. Well, this is negative 7 pi over 6. So what do I do differently? Go the opposite way, but I go the same amount of distance. So it's still this amount of distance, but I go this direction. So this time I'm going to erase it and I'll do it right. Now you can pick up with me if you want. This would go around the circle this way, negative 7 pi over 6 distance, which takes me to there. However, I'm going to erase this now as well, so we're not confused. I also have a -1. What does that mean if you have a -1? So I want to put negative 7 pi over 6 right there. Do I actually go towards 7 pi over 6? I go away from it. So the point is actually right here. Let me go across so you can see I go this direction because it's a -1. This would place point S right there. Questions over plotting polar points? All right. The next thing we need to look at with polar is where polar is quite a bit different than rectangular graphing. Remember, rectangular just means X and Y. Where it's quite a bit different is that each point can actually be listed in any one of 4 different ways. So that's what I'll walk you through here. So let's first, I want you to plot where you think 2, 3 pi over 4 would be. I want you to go ahead and do that while I give you just a moment. I want you to think about where would you plot 2, 3 pi over 4. Where do you think that would belong on this polar graph? So once you determine where you think it'll be, plot that point. 3 pi over 4 is like it's the middle finger on your hand trick, which means it's the middle of the quadrant. What quadrant is 3 pi over 4 in? Second. Okay, so 3 pi over 4, you should have gone second quadrant and 2 circles towards that value right there. Now that would be the point. So now I'm going to add, this is the first way. There are, it says 3 additional representations. So if the first one's given to us of 2, 3 pi over 4, what I'm about to walk you through is that each point can be written 4 different ways. So I'll do one in red, I'll do another in blue, and I'll do the last one in green. There are 4 different ways, and you can do it by formula, but first I'm going to just show you visually so you can see it. So in black, what is represented in black? That means you go to the second circle, and we went around 3 pi over 4 radiuses going this direction. So I'm going to kind of draw this in black so you can see. This was the first way of writing this polar point, is I went around the circle in that direction. Does that make sense to you? Okay, here's another way I could do this. What I could do is I could go around the circle this way, all the way to that point over here. Now, if I went in that path, I'm still on the second circle, so that's still a positive 2. But you know what's different this time? I went a negative distance. Now, how much distance, how many radiuses did I travel? Well, I did travel a negative amount. Well, think of it this way. How much apart, or what is it? How many radiuses does it take to go full circle?
7.
2 pi. So what I've done here is I've gone a negative amount from 2 pi. This would be 2 pi going down this way. If you think about this being 1 pi over here, going this direction, 2 pi would be, if you started this way, went here. I went 2 pi a certain number of negative amount. Well, how much did I go? Well, if you took it 2 pi away from 3 pi over 4, you would get the amount we traveled. So here's what I'm going to do. I'm going to take 3 pi over 4, and I'm going to take away 2 whole pi's, because that's how far apart they are. It's a full circle apart. Now, if I took 3 pi over 4 and took away 2 whole pi's, I would get whatever this amount is. Now, I want you to think, I'm going to multiply by a funny looking 1 here. To get a common denominator, I'm going to multiply this by 4 over 4. So what is 3 pi over 4 minus, this becomes 8 pi over 4. What's 3 pi over 4 minus 8 pi over 4? Negative 5 pi over 4. That's the other way. That's another way we could write that point. Now, what I just determined is this is right here, negative 5 pi over 4 going this direction. I'll just go ahead and include that somewhere. Negative 5 pi over 4. That's how many radiuses, how many radians it took going this direction. Okay, I've done 2 of them. Can you think of another way we could get to that point? What's another way we could come to this point right there? I'll go ahead and put this over here.
If you go across a negative and then have a negative.
That's right. What we could do here, this is the next one in blue, is I could go this way. I could go this amount of the radius, but then jump all the way across this direction. Like that. Now, how would I do that? If you jump across the pole refers to the origin, what you've done is you made it have a negative r. So now I would have a negative 2. Wait, why is it a negative 2? Because I'm jumping across the pole. You see how I jumped across the pole there? Now, how many radians did I go if I went this way? Is it a positive amount or a negative amount? That is a negative amount. And how much negative amount is it? Well, here's what's nice about radians. You'll notice they're all going to be the same denominator. So how many pi's over 4 do you think I went this way? Negative 1 pi over 4. And so that would be our third value. Now there's one more way to get to that point. Anybody else know the other way to get to that point?
Go across all the way around and then do a negative.
You got it, Guadalupe. If we went all the way around, so if I went all the way around the circle, this would be a very slow way of viewing this. But if I went all the way around like this, and then went across, that's my other way of getting there. Now, going all the way around and then across, how many, by the way, if you jump across, what does that do to your r?
Negative.
I would have a negative r, so negative 2. And then going all the way around, this way, this is a positive amount of radians. How many radians did we go if we went to the pi over 4 in the fourth quadrant? 7 pi over 4. This time we would refer to that as 7 pi over 4. Okay, so now I'll let you see the formula. The formula up at the top of the screen tells you that what you can do if you have any one value is that you can add or subtract a 2 pi to the angle. So for example, the first formula right here, let me get a different color so it stands out. This first formula, I want you just to look at the first formula there. If you took any one of the points, so let's just take the very first point, it says you can add a 2 pi to n pi, but I'm going to just say 2 pi to it to get your other value. So for example, you could add or subtract, by the way. If I took this and I subtracted a whole pi, subtracted 2 pi's, what would I get? If I took this and subtracted 2 pi's, I would get this value right there. We already did that. Where did I do that? Oh, right here. That's what I did. That right there was that formula. I took the angle. What was our original angle? What was our theta? 3 pi over 4, and we subtracted 2 pi's. Remember, with n, it could be a positive number, it could be a negative number. It just has to be an integer. I should have written that on there. Go ahead and add that to your notes. N is an integer here. Cannot be a decimal, it cannot be a fraction, but it can be a positive or negative whole number. So I forgot to include that in the formula. Let's add that in. That's what I did there. Now to get the other value, this 2n plus 1 means you can add an odd number of pi's. You can add an odd number of pi's to get a negative. So for example, if I took this same first point here, what I could do is I could change the r to be a negative and add or subtract an odd number of pi's. And that's what I did here and there. So this one, notice both the r's went negative. This first one would be subtracting 1 pi. That would be subtracting 1 pi. Would give you negative pi over 4. And the second one would be taking 3 pi over 4 and subtracting 3 pi. No, it would be adding 1 pi, I'm sorry. That would be adding a pi. And that's how they got that's how we could get all 4 points. Okay, so one more time, what's that formula saying? Is that if you have any one point, you can add or subtract pi's to get all the values. That's all it's saying. It's a complex way, goodness gracious. It's a complex way of saying if you add or subtract pi's, you can get all your values. If you're adding or subtracting 1 pi, that's what I have in purple. What happens to your radius if you add or subtract 1 pi? Well, stay with me. Come on, Jaden. Stay with me. What happens to the radius from number 1 to number 3 or 4? It changed. The symbol, the signs changed. So if you add 1 pi or an odd number of pi's, add or subtract, the radius will change. What happens if you add a 2 pi? It'll stay the same. Yep. And that's what it's walking you through there. That's what that formula is all about. So what do I want you to know so far? When we graph in a polar system, what type of values am I giving you if I give you the polar coordinate system? I'm giving you 2 variables. What are they? R and theta. How many ways can you plot any one point in polar? 4. Can you do the same with x's and y's? No, you can only point it one way. If it's a positive x, you go which way? Always to the right. If I gave you a negative y, which way would that go? Down every time. With r and theta, it's different. You can plot any one point 4 different ways. All right, with that, we're going to convert. I'm going to show you the relationships, and then we're going to start practicing some other stuff. So here, all that's happened is we've solved some formulas on this page. Don't overthink it. I have a diagram here to walk you through. Since the beginning of, or since we came back from Christmas break, the thing I've been saying over and over is that sine is y, cos is x, tangent is y over x. And what they've done in these formulas for polar is on the first two, they took the sine is y and cos is x, and all they did is they isolated the x and the y. Truthfully, sine is y over what letter? R. If I multiply both sides by r, guess what I get? If sine is y over r and I multiply both sides by r, I get y equals r sine. Okay, same thing. If I took cosine is x over r and I multiply both sides by r, guess what I get? R cosine equals x. That's all I did is they isolated that variable. Okay, over here, this is the Pythagorean theorem. You've seen that before, and we're going to use tangent. These are the four formulas we're going to use over and over. This has a note: x cannot be 0. Why can x not be 0? Not allowed to divide by 0. Very good. Very good. This is going to walk you through. If you get stuck later on, you can refer back to this. The one thing I would suggest is I couldn't figure out how to make PowerPoint do this without messing it up. Do this as 2a and change the 3 to 2b. I just could not get it to format right with the spacing. Meaning you don't do step 1, 2, and 3. You do 1 and you might do 2a or you might do 2b, but you don't do both of them. You do one or the other. Okay, so just do that, change that to 2a and 2b. Here's your diagram. Showing you the representation of everything. X, no surprise, looks like an x-axis. Y looks like a y-axis. R looks like a hypotenuse. And here looking at it as a triangle with theta. Theta is always in standard position coming from the positive x-axis. Okay, there's your diagram. So, how are you feeling so far? Tired. Oh, come on. Okay, so let's get started. What we're going to do here is we're going to find the rectangular coordinates. Let's pause. What does it mean to be rectangular? That means find the x and y coordinates for the points given by these polar coordinates. So if it's polar, what does it mean it's given it to you as? R theta. Okay, so how do I get my value x? What was the formula? X is equal to r cosine theta, and what was y equal to?
R sine theta.
Okay, good. Let's substitute in and solve these. So that means x would equal, what's our r? 3 for part A. Cosine, and our theta is 5 pi over 6. And for y, it'll be 3 sine 5 pi over 6. Now, something I want you not to mess up here, and it's very easy to do. If the radians are outside the first quadrant, I'd recommend you do a quick little unit circle to help you out on whether these need to be positives or negatives. So the positives and negatives have nothing to do with whether these values are positive or negative. It has everything to do with where it would be on the unit circle. What quadrant is 5 pi over 6 located in? 2. Draw a little arrow there. And what I want you to put is that in the second quadrant, tell me about x. Is x positive or is x negative? I want you to put that x is less than 0. Tell me about the y. Put y is greater than 0. Okay, come back over here. That's going to help us out. Since x is less than 0, it's got to be -3 times, and we're going to do hand trick. Show me your pi over 6 finger. Do I look at the palm of my hand or the back of my hand if it's a pi? Palm. Looking at the palm of your hand, which one's the pi over 6 finger? Ring. So spin the ring. You know what? Actually, I'm gonna make this mathematically correct. The negative is actually going to come from the cosine, so I'll put it there. I'm going to do it this way for the notes. Okay, it's the ring you said. Flip your hand over. How many cosine fingers do you have if your ring finger's bent? You're now looking at the back of your hand.
3.
Cosine at the bottom, you have 3 cosine fingers, so it's square root of 3 over. What is cosine always divided by? 2. Alexander, what's cosine always divided by? 2. Okay, let's do the sign before we put away our left hand. This is 3 times. Was the sign going to be positive or negative? Hey, I want to make sure I didn't go too fast. Where did I get the positive and negative? I got it from here. Cosine's what letter? X. Because x is, since we're on the left side of the unit circle, x is going to be negative. That's why. The y, will it be positive or negative? Positive. Would it help you if I put a plus there, or are you good without the plus? You're there, you're good without the plus. Okay, I'll take that away. All right, how many sine fingers do you have in that location? 1. I'll put it unreduced, so it's the square root of 1 over 2. What does that mean for my final answer? you would just simplify and you would get rectangular goes in parentheses as x comma y. I would have negative 3 square root 3 divided by 2, comma. What is the square root of 1? 1. So 3 times 1 is just going to be 3 over 2. That's your answer to part A. We cool with that? Okay, the second one. We could do it exactly the same, or if you wanted to, we could rewrite this in one of those 4 forms. I'm going to change this to get it to one of the 4 forms that's better. I don't like this negative angle. How could I change the angle but not change the radius? I want you to think of a unit circle. What can I do that's coterminal to change the angle but not change the radius?
Make the beta positive.
Now, how can I make it positive? Do I add 1 pi? Do I add 2 pi? If you add an even amount of pi's, the radius does not change. If you add an odd number of pi, like 1 pi, 3 pi, 5 pi, the radius would change. Do we want a radius to change? So we need to add an even amount of pi. So I'm going to take, still going to be 2, negative 7 pi over 3. That is approximately how many negative pi's? If you were going to give it to me as a rounded decimal. What is negative 7 over 3 approximately? Negative 2.3. So how many pi's should we add to get to a positive amount?
2.
With negative 2.3, we need to add, let's add 4 pi. So if I want to add 4 pi, let's get a common denominator. I'm going to add 4 pi. I'm actually adding just writing it all out so you can see the math later on. What is a negative 7 pi plus 3 times 4 is 12? What's a negative 7 plus 3 times 4, which is 12? 5. It'll be 5 pi over 3. Now, if I added 2 pi, it still would have been a negative pi. We could have done that. You know what? We could have done that. Let me go ahead and write it down below. We could have taken negative 7 pi over 3. How about this? I'll put or and added 2 pi. And still done the same thing of 3 for common denominator. If I had done it that way, I would have gotten 2 comma, this is 6 now. It would have been negative pi over 3. Now that still would be pretty easy. Y'all would probably know where to plot that. What quadrant would this go in? Nah, it's negative. It's not third.
2.
That would be fourth. What about this one? They should be the same. Where's that one going to be? Fourth. That one should also be fourth. Okay, so we don't forget, just go ahead and draw yourself a quick unit circle. Just a quick sketch. We're in the 4th quadrant. Pi over 3. Is that close to the pinky or close to the thumb? Which way should I draw it to be more appropriate? So pi over 3's close to the pinky, the thumb. So draw it closer to the y-axis. What can you tell me about the x's in the 4th quadrant here? Are x's positive or negative? Positive. What can you tell me about y's? Negative. That'll help us with our answer. Okay, so now let's find our values. So after all this setup, we can finally find our values. The x would equal, what's the formula again for x? R cosine. So this time I'm just going to plug it in. 2 cosine of, which angle do y'all want to use? 5 pi over 3?
Yeah.
Let's use 5 pi over 3. We did all that work. Let's use that one. And before we solve that, we'll go ahead and write down the y. Y is just going to be 2 sine of 5 pi over 3. Because sine is y and cos is x. All right, hand trick time. Go to your hand trick. 5 pi over 3. Which finger is the pi over 3 finger? I need more people. You're on all over this, Fury. Can I get more people though? Look at your hand. I don't want to be going too fast, so I want to make sure I'm slowing down enough to at least let you try. Which finger is the pi over 3 finger? Index. Spin your index. Flip your hand over. How many cosine fingers do you have there? 1. And cosine's supposed to be positive or negative? Since cosine's x. Positive. So 1/2. Let me put the square root there. Since it's a 1 finger. Okay, and then what about for sine? It's supposed to be a negative. How many sine fingers do you have there? 3. So it'll be square root 3/2. So my final answer would look like this. What is 2 times 1? 2 divided by 2? We'd have a 1 there, and here I'd have, that's just going to be negative square root 3. The 2's will cancel each other out. That is my second point. Okay. Let's take a look at now going the opposite way. So part C and D, this time it says find the polar coordinates of the points given the rectangular coordinates. So what am I being given this time? I'm given the x and y, and we're looking for r and theta. Okay, so the formulas, the Pythagorean theorem is x squared plus y squared equals r squared. So to get r isolated, what would you do to both sides? Because right now it's not isolated. Yes, you would take the square root. Now by rule, r is supposed to be positive when you do this. So I'm not going to do the plus or minus. I'm just going to take it as a positive. So r will equal the square root of 1 squared plus negative 1 squared. Now I need to put that in parentheses. All I did is I plugged in my x and y. Okay. So that means r is the square root of 1 squared is 1. What's negative 1 squared? So 1 plus 1 is 2. R is the square root of 2. Now here's what's tricky for the theta. The theta depends on what quadrant it should be in. Positive 1 comma negative 1. What quadrant is that located in? The 4th quadrant. That is right 1, down 1. That point is somewhere over here. Actually, I shouldn't have drawn the circle. Let me do this again. Because we're not on the unit circle right now. Just draw this point right there. That's 1, negative 1. Now here's what I want you to make a note of. When we do, how you get your theta is you use the tangent formula. So remember on part A and B, we were using the cosine and the sine formulas. Cosine and sine go together when you find x and y. Well, when you find r and theta, you use Pythagorean and tangent. What is tangent's formula? Tangent is y over x, which means tangent theta is going to be, well, I'll get to that in a second. To isolate the theta, what's the opposite of doing a tangent? The cotangent's the reciprocal. That would be flipping it to x over y. What we're going to do is inverse tangent. And what's our y value in this problem? And what's our x value? 1. Okay, here's the problem with inverse tangent. If you remember, with inverse tangent, it restricts this side of the graph. Inverse tangent has a restriction. The inverse tangent will not find a value on the left side of the graph. Now this problem, we're good. You see how it's on the right side? So whatever the calculator tells us this is, would be the right answer. I'm actually not even going to use the calculator because we can do this as a hand trick. If I'm looking for the tangent when the y and x are equal to each other, we can do this on the hand, and I'll rewrite it. You could have done it. I could rewrite it. Negative 1 divided by 1 is the exact same value as negative square root of 2 divided by the square root of 2. Is that still negative 1? Yeah, okay, so if you're doing an inverse, which side of the hand do we look at? Do we look at the palm of our hand or the back of our hand? Okay, go to the back of your hand, and we want the y's to be square root 2 and the x's to be square root 2. So I need 2 fingers for y and 2 fingers for x. Which finger do I bend? Middle finger, bend your middle finger, flip it back over. What is that? Pi over 4. Because it's in the fourth quadrant, because that's a pi over 4 finger in the fourth quadrant, we would call this a negative pi over 4. So our final value would be the square root of 2, that's the r, and comma, negative pi over 4. That is a correct answer. Okay, now really quickly, what if this had not been, you know what, I'm gonna just change this one. Rather than change this problem, how about I change D? D says 2 comma 0, let's change this to negative 2 comma 0. This will be better math. Change that to a negative 2, right in there, sneak in a negative. Because now I get to show you what I meant with the tangent restriction. Okay, let's walk through it again. What is the formula to get our r? The square root of x squared, so negative 2 squared, plus y squared, 0 squared. Which means, and to change colors, which means negative 2 squared is 4, 0 squared is 0. And what is the square root of 4? 2. We have an r value of 2 this time. Now the formula for theta, before you go further, when you are switching between x's and y's, what in the world? When you are switching between polar and rectangular, you need to use an XY chart, sometimes a unit circle, depending on which values, to think about what type of answer we should get. Now this one, we don't even have to do an inverse tangent, but that's where our point is right there. That's point Q. But I'm going to go ahead and write this out. You probably know what the theta is going to be. What theta is going to be on this negative x-axis? How many radians does it take to get over there? Pi. It's going to be pi. But let's just pretend we don't know that. Here's what you would do. You would say theta equals the inverse tangent of y. What's our y? 0 over our x. Negative 2. Which, if you wanted to use your hand trick, that's the same thing as tangent inverse of square root 0 over negative square root 4. And now we could use hand trick. Okay, so go to your hand. You're looking at the back of your hand. You need 0 cosine fingers, but you need 0 sine fingers, but you need 4 cosine fingers. Which finger do you bend? Pinky. Bend your pinky, flip it over. What's your pinky represent? 0, no denominator. Now here's the problem. A tangent restriction only finds the right side. Our point is where? Is our point on the right side of the graph? No. So what do you do if the calculator restricts this part, but you know the answer is supposed to be over there? Well, this is where you go to 2b on this chart. You remember this chart I said name it 2a and 2b? Well, 2b tells you if the point is supposed to be on the left side of the graph in quadrant 2 or quadrant 3, then you just simply add pi. That's all you have to do. So you add pi to the answer. So I come back to this problem, and we're going to say that theta is going to equal this inverse tangent plus pi, or in this case, plus pi. And so what do we get? We get that our value is 0 plus pi. It was 0 on the hand trick, plus pi. What is 0 plus pi? So now we know our point. Our point is 2 comma pi. 2 comma pi is equivalent to negative 2 comma 0 in rectangular. 2 comma pi is a polar coordinate, is equivalent to negative 2, 0 as a rectangular. Okay, you've seen me practice a whole bunch. I know you've been wondering, when is the DOL coming? Well, it's here now. The first one is polar. I want you to convert this to rectangular. Your second one's rectangular. I want you to convert that to polar. So please go ahead and do that. DOL number 1. Okay, example 4. Now what we're gonna start doing is we're gonna start converting equations. Honestly, this takes, it's the same 4 formulas we've been working on, nothing different, except we're now gonna deal with equations. So if I'm gonna switch from one equation to the other, you just need to remember all 4 formulas. I'll write them up at the top. What was it that x was equal to?
R cos theta.
R cosine theta. Okay, make sure you, if you need to rewrite these, go ahead. What is y equal to?
R sin theta.
Very good. What was the Pythagorean no, wait, tangent? And I'm gonna write this one this way because a lot of times with equations, you don't do the inverse tangent. You would do like that. And then finally, the Pythagorean theorem. What was that formula? Okay, that's the formulas we're gonna use. So on this first one, if I want to change to convert forms, I have a y first. What can I replace that y with? R sine theta. So R sine theta equals 1/2. Now x squared, you could replace it with, over here, you could subtract y squared. I'm not going to do that because I want to get rid of my y's. I'm going to use, in x's, I'm going to use this formula. You do have an option though. So I want to replace the x with r cosine. And that x was being squared, so I need to square that parenthesis. Now the goal in polar equations is to solve for r. So we got to get r by itself. So here's how I do that. First, I'm going to multiply. According to PEMDAS, I need to do the square first, which a square is just multiplication. I need to multiply all of this out. So I will have r sine theta equals 1/2 times r cos times r cos. And before I start to multiply all this out, do you see anything that you could simplify right now? The r's. I could divide out an r from both sides of the equation. Why can I do that? Because r can never be 0, so I'm allowed to do this here. I can divide out one r there and one r there. So what am I left with? I'm left with sine theta equals 1/2. What's a cosine times a cosine? Yeah, that's right. And it's not that the angle that's squared, it's the cosine that's squared. So you put the square on the word cos, not on the theta, like that. Okay, the next thing I'm going to do, I'm trying to get this r by itself. How about we get rid of that fraction? The way to get rid of a fraction is to multiply by its reciprocal. The reciprocal of 1/2 is 2/1 or 2, that's right. So I'll multiply by 2/1 on both sides. So that will simplify there. And so now we have 2/1 times sine is just 2 sines equals r cosine squared theta. Now we're at our, what would be the last step if it wasn't for trig. How do I isolate my r now? Divide. It's multiplying, it's being multiplied right now, so we'll divide by cosine theta. Well, there's another way I could write this that we learned about last class, and it's this. I could rewrite this as 2 sine theta over, and instead of cosine squared, I'm going to write it as a cosine times a cosine. And the reason I'm going to write this, I'm going to break this down and write it one more way, a little bit simpler. So right there is the basic math. What I'm doing is rewriting this in trig functions to make it simplified. I'm going to write that this is equal to r equals 2 times. Do y'all remember what sine divided by cosine is equal to? That's a y over x. What's y over x? That's a tangent. And do you remember, if you're dividing by cosine, that's the same thing as multiplying by a different trig function. It's a reciprocal. If I divide by cosine, that's the same thing as, I heard someone say it, dividing by a cosine is the same thing as multiplying by a secant. Secant. That's my, let me do that. That's going to be my answer right there. Now, if you want to note that, how did I get that? This right there is the quotient identity. That's the quotient identity. That right there was a reciprocal identity. Now this says we could graph these just to confirm. And I'm not going to do this all day because this would take a lot of time. Too much time that I don't want to get into today. But I'll just graph it one time to show you. Here's the equation. I'm going to change my mode. I'm going to go menu, graph entry, and I'm going to choose a relation. So I can just type this in as y equals 1/2 x squared. Let's see. Okay, what does that look like as a graph? Parabola. And now I'll graph the other one as a polar equation. How do you do that? You go menu, graph entry. You slide down here to number 5. It says polar. I'm going to graph this. What was our equation? It was 2 tangent theta. Theta's with the pi button times the secant of theta. Is that right? Times the secant of theta. When I click enter here, what do you notice about this graph? They're one and the same. So did we do it right, our math right? Yes, we did. Yes, we did. So I'm going to take this away here. Okay. All right, let's look at part B here. So part B, using our 4 formulas up the top, I see I have a 4x squared, y equals 1, and I know there's a x squared here, but substituting that with it's just going to get messy if I do it that way. So I'm going to use these 2 formulas here. I think it's going to be the easiest way, and we'll find out. I could be wrong as we go, but I'm going to assume that this is the best way. So I'm going to say this is 4 times r cosine theta squared. And then that will be multiplied times the y, which is r sine theta. And all that needs to equal 1. Now again, according to PEMDAS, we'd multiply first, and that would just mean multiply r cosine times itself. So here's what I would have. I would have 4 times, this is a r times a cosine times another r times another cosine. And then we'll have a times r times sine. There's going to be r cubed. There's going to be 3 r's, 2 there, and now I'll have times cosine squared theta times sine theta. Now, as you notice, that's a whole lot of stuff going on. Well, to simplify this equation, I want to get r isolated. So what I'm going to do first is I'm going to divide everything by 4 cosine squared sine theta. Divide everything here by 4 cosine squared sine theta. So what's that do for me here? Cosine squares get simplified, sine squares get simplified. So I now have r cubed equals 1/4. Now, cosine in the denominator, dividing by a cosine, if you think about it this way, is a secant. Now, because it's the squared, it becomes a secant squared. And then dividing by a sine. If I divide by a sine, that's the same thing as multiplying by a cosecant. And so I'm going to write that as a cosecant. Whoops, that's a cosine. Cosecant, CSC. There we go. Theta. And so now I'm really, really close. That's r cubed. What I could do if I wanted to is to isolate that r is I could take a third root. The opposite of a cube is a third root. A third root. And so I'll say that r is equal to the third root of 1/4 secant squared theta cosecant theta. Now that is a crazy equation there. Let's check the graph. Here I already graphed the rectangular version. Now I'm going to graph the polar version. It's the third root of 1/4. Let me actually get this right. Control divide. There we go. 1/4. This is a secant. Secant. Where's secant? There it is. Secant theta. Whoops. And a little note here, on the calculator, when we have a secant squared, you have to put the squared outside the parentheses, not in front of the parentheses. The calculator errors out. It's just kind of a weird programming thing there. And then is multiplied times a cosecant. Now press enter. You can see that these graphs are matched up. I meant to put this in the second spot. Hang on a second. Let me copy this out of here. I'm gonna go Control X. And now menu 3 graph entry. Sorry, let me do it as R2 so it gets a different color. And you can see that the graphs are basically the same. We're having a little error there, and the calculator is trying to figure out what to do, and it connects those pieces rather than sending it off this way. But that is, in fact, the right equation. So we did do it correctly. It just looks a little funny right there. Okay, so let me take that back over and I'll add it in. All right, now let's look at example C here. What if we had to convert from polar to rectangular? How would I do so? Well, I'd still use the same 4 formulas. Let me go back and copy these. I'm going to still use these same 4 formulas. So if I were going to convert from polar, I would still use these same 4 formulas. Okay, so I have a R, and that's all I have. Which formula do you think is easiest to use if you only have an R? I hear Pythagorean. I agree. I'm going to use this one. What do I need to do to change to get this the same as the R in this formula? Squared. Let's square both sides. If I square both sides, guess what I have? I have R squared. What is R squared the same thing as? X squared plus Y squared. And what would that equal? What's 4 squared? 16. Believe it or not, that's the answer. Now, mathematically, what we don't get to hit much because this is unit 4 and we're in unit 3. Mathematically, once you have an equation that has x squared and y squared, you don't solve for y anymore. You don't isolate the y. You leave x squared and y squared together on the same side of the equation. That's what this equation would be. Let me show it to you. I'll go over here and I'll type them in. This equation now is x squared plus y squared needs to equal 16. When I press enter, what shape do you see there? A circle. And what was our original equation? It was that r equals 4. And guess what that is? It's saying it has a radius of 4. What shape has a radius? A circle. And if it's just a radius of 4, guess what it is? A circle with 4 all the way around. Notice how that worked for us there. So again, I'll add these in later on. Since that one went so quick, let's do one more. Okay, take a look at this one. What formula do you think would be best to use if you're given a theta? And by the way, there's no necessarily wrong answers. I might just tell you I'm going to do it a different way, but I'm not going to count you off here. Which one do you think we should use here? How about tangent? Tangent's pretty simple. There's no r's with it or anything like that. So this is just a theta. What's it missing? What's this part missing? It's missing the word tangent. So what I'm going to do is take a tangent of both sides. If I take a tangent of both sides, we have this set up. Well, now what can I do? Well, what is tangent of theta? What's an identity for tangent of theta? Y over x. And that would equal, now this is a hand trick. We could find what that is, but before I risk messing up, 2 pi over 3. What quadrant is 2 pi over 3 in?
First.
Not first quadrant.
Second.
It's second quadrant. Now, where on the hand, to make sure I draw my arrow right, is it closer to the y-axis or closer to the x-axis? The 2 pi over 3. Which one's your pi over 3 finger?
X.
Index, which is closer to the y-axis. Okay, now why do I do that? This tells us if we're going to have a positive x, positive y, negative x, negative y. What are we going to have as far as x is concerned? X is going to be negative. What about my y? Positive. Okay, now let's use our hand trick. Take your 2 pi over 3 finger, which is the pointer, bend it, flip it. The y there, what's the y value? Square root 3, and it should be a positive square root 3. And what's our x? Negative square root 1. Now I'm gonna simplify this. What do I do with this x right here to get, because these aren't squared, I'm gonna get y isolated. Because y is not squared, I'm gonna set it equal to y. How do I get rid of this x that's dividing? You multiply both sides by x. And so what am I left with? I'm left with y equals square root of 3 divided by negative square root of 1. What is the square root of 1? 1. So it's square root of 3 divided by negative 1. So it's just negative square root of 3 x. There's our equation. Now, what does that look like? I can't graph this one in my Inspire. I cannot do it, but I can graph the negative square root 3. If I graph the negative square root of 3, y equals negative square root 3 of x. It's this line. Let me turn this one off. It's this line, and you know what that line represents?
Slope.
This same line we drove over here. It's the slope that would be through 2 pi over 3. So we did do it correctly. That is it. That would be 2 pi over 3 lines right there. That would be the line 2 pi over 3. Okay, so once again, I've done a few, and I'm going to let you try this one. Okay, so I want you to think through the 4 formulas. You might need to do a little 3-12 lesson first to be able to find it out, but go ahead and do this. DOL number 2. Okay, now we're going to switch gears and talk about imaginary numbers, or a complex number, I should say. What is a complex number? A complex number is a number here, that complex that has a real and an imaginary number. So how we graph these, I'm going to graph and show you. I have down here 6 total complex numbers. We'll call them A, B, C, D, E, and F. There's 6 complex numbers. How we graph these is their real number is plotted on what appears to be an x-axis. We're not going to call this the x-axis. We're going to call this the real axis. The y-axis is going to be called the imaginary. And that's what the letter I stands for. So this part ought to be really fast. Where do you think 3 plus 4i should be plotted?
7, 9.
Not 7i? Nope. Where do you think we should plot it? 3, 4. Very good. 3 to the right, 4 up, plot that point, and write an A there. What about B? 0, 2. Now, I wrote it that way just for you to figure out. Now, in the future, do you think they would place a 0 there? If you had 0 plus 2i, what's another way we could say 0 plus 2i? Just 2i. So I'm going to put an x there, and just so you can see that I just wanted to write it that way for you this first time. What about negative 2 plus 3i? Left 2,
Up 2.
up 3, that's point C. And D, negative 4 plus 0i. Do you think we would actually write it that way? It would just be negative 4. And how would you graph that one? Left 4. That's D. Okay, I want you, DOL number 3, plot E and F. All right. So the absolute value of complex numbers is what you're going to see here. You see the symbol that looks like by the way, the lowercase letter Z means complex number. If you see this absolute value, what it means is just the distance. It refers to, it's very similar to the R. So I want you to put this down here. I think I wrote it later on. I just did not get on this lesson, this slide. Come over here and put R equals that absolute value of Z. The absolute value of Z is it's telling you the distance of that point that we've just been plotting. Okay, what does that double R looking thing right here mean? The real axis. What do you think the I stands for?
Imaginary.
Imaginary. This is telling you it's a complex number. Here's your real portion. Here's your real part. A is your real part. B is the imaginary part. The absolute value of Z is like the R. That would be the distance to get there to that point. Okay. Same 4 formulas that we're going to be using that we've been using. Now they just switched up some variables. They're not going to call it X and Y. They're going to call it A and B. They're not going to call it an R. They're going to call it an absolute value of Z. Theta stays the same. Okay, so here we go. So if Z were negative 5 plus 12i, find what does this absolute value of Z mean? It's like the R. Okay, let's plot this. Where do I go with the negative 5?
To the.
left 5, and we're gonna go up 12. So just plot a point somewhere. And I'm gonna call it, let me use some of my tools so I don't have crooked lines here. We're gonna say that's -5, or excuse me, that would be a height of 12. And I'm gonna call this -5, and we're gonna find what is the distance from here to there. Okay, so A equals -5. The B equals 12. That they use the letters A and B here. We want to know what is the absolute value of Z and what is our theta here. That's what we're trying to find out. Okay, so the formula is, as you can see, it's the Pythagorean theorem. It's because we have a right triangle here. This is a right triangle. It would be the square root of x squared, which is, in our case, the A, -5 squared, plus the B squared, the y squared, just the 12 squared. I'm not putting the I in here. I'm not including the I. That's just telling you it's the imaginary part. So a little mental math. Who knows what -5 squared is? -5 times -5. 25, great. And who knows what 12 squared is? 144. Does anybody know what 25 plus 144 is? And anybody know the square root of that? 13. Okay, so the distance of Z, the modulus is what you can call it, is 13. That's a word you might see. Let me go back and show you that. The modulus of the complex number. That just means the distance. That's the distance. You know why they use the absolute value symbol? It has to do with the word distance. Distance can't be negative. And when you do this formula, you're always going to get a positive answer. That's why they use the modulus, the absolute value, is it's telling you that you're always going to have a positive answer there. Okay, so that's why they use that symbol to represent. That's its distance. So we just found out that this has a distance of 13 units. Okay, now how can I get my theta? What was our theta formula? Do y'all remember? It came from the tangent. Tangent theta is equal to y over x. So tangent here is going to be inverse tangent of what takes the place of y? 12. And what takes the place of x? Now I'm going to do something here. I'm going to have to add a pi. Now, why do I have to add a pi? Because tangent inverse restricts this side of the graph. So how do I get around it? Since I'm supposed to be on the left side, I'm going to add that pi. That'll make up for it. So let's go to our calculator and figure out what this is. So I'm going to just go to calculator and make sure you're in radian mode. Trig tangent inverse of 12 divided by -5. And I'm going to put a plus pi in the outside. Plus pi. I'm getting 1.9655. Okay, I'm going to get you ready for the AP exam. I've been learning that you're on the AP always rounding to the nearest thousand. How many decimals is that? 3. You're always rounding to 3 decimals. So let's do that. So would I say 1.965 or 1.966? 1.966 is going to be our answer here. We're going to take 1.966. So theta equals 1.966 radians. Okay. Wait, why did I add theta? Will we always add a pi? When will you have to add a pi? When you're on the left side of the y-axis. That's when you add a pi. Okay. That takes you to this DOL. Go ahead and try this one. All right. So now let's talk about the polar form of a complex number. The same thing we've been doing. What I just walked you through with those complex numbers, those were in rectangular form. I just given you x and y's. We could also do this with r's and thetas. There's one substitution we need to make. Here's where I told you. I knew I had r equals absolute value of z. If you were using cosine here, You would not use the letter X. What takes the place of X? Okay, so it's going to say cosine is A over, and I messed this up. I put an R there. What should I have used for complex? Not an R, but absolute value of Z. That's what should be there. Whoops, my bad. And that would also make this when you change it. And now I have it right. No, hold up. Maybe no, I'm gonna take this way. I forgot because the polar form, they do use the letter R there. We're fine with the R's. Never mind, we're fine. I just like to make y'all panic for a second. Just like to stress you out. You don't have enough stressors in your life, you know? Need another one in math class, right? You can leave it. We'll leave this. We'll say it's right. Okay. Let me think. What do I need to put up here? The number R is the modulus and theta is the argument. Oh yeah, if you ever hear me say argument, I'm talking about the inside of a trig function. That's what they call the argument, which you've heard me say that before today, but I'll just remind you. Argument is the inside value inside of a trig function. Okay, so here we go. Write this complex number in polar form. So that means it's given to you in rectangular form. So the square root of 3, what letter does that represent from these four options? What do you think that is? That's the A. That's your A, square root of 3. The I's coefficient is the B value. How many I's do I have there? 1. So B is 1. How do I get the R value? Pythagorean theorem. We're going to take the square root of
3,
the square root of 3 squared plus
1.
1 squared. Well, what is the square root of 3 squared?
9 squared?
This is the square root of 9. What is the square root of 9? 3. So it's the square root of 3 plus 1. What is 3 plus 1? 4, which means this is 2. All of this is going to equal 2. R is 2. Now, how would I get my theta?
10.
Inverse of what's in place of y? 1 over. By the way, this can be a hand trick if I just put a square root over this. By the way, what quadrant would this be in? First, so do I need to add a pi? No adding pi, because we're good. And I can plot this point. I'm just going to go somewhere out here. Square root of 3 is approximately 1.73. So I'm just going to make it about right there. And if you wanted to label it, you would come down and on the real axis that represents the x-axis, that's where you would put a square root of 3. The imaginary axis gets the 1. Like that. And here's our point here, which we just got that our z value. I'm going to use the letter z is 2. We already solved that. That's right there. Okay. So inverse tangent, let's do a hand trick. If you're doing an inverse tangent, which side of the hand do you look at? Palm or back side? Let's look at the back side. I need 1 Y finger. I need 3 X fingers. Which way bend?
Index.
Index. Flip that hand over. What is that?
Enter.
Did I say index? I'm sorry. What are we bending? Ring finger, ring finger, ring finger. That's what we're bending. What is that going to be? Pi over 6 finger. That is our pi over 6 finger. So theta is pi over 6. There we go. And that's how it would look. So hopefully now that you've seen this, this is example 7. You've seen this about 7 times. Hopefully now that some of this is starting to click. The process works the same, whether it's real and imaginary, whether it's x's and y's, rectangular, whether it's polar. Hopefully some of this is starting to click in. All right. Which brings you to DOL number 5. No, it doesn't. I forgot to write polar form. Here's how polar form looks. My bad. Go back. Polar form looks like this. The polar form looks like z equals, you put the radius. What's our radius? parentheses, your cosine of the angle, which is 5/6, plus I sine of the angle, which is 5/6. That's what you need for polar form. Sorry. Again, I want to make you stress out. Back and forth, back and forth. That is polar form. The standard form or the rectangular form is what was given to us up here. That would be like the standard form or the rectangular form. This is the polar form when you write it that way. Okay, your turn now. Deal number 5. Let's look at example 8. Let's go backwards here. It says write this complex number. This right here is polar form. Just right up above it, put polar form. Polar form. So what's it mean if it's in polar form? This 5 is your radius. And the theta is given to us. The theta is
Cos.
not the cos, just the thetas, which is 3 pi/4. So what do I need to find? I need to find my a and b. So a is like x, b is like y. What's the formula to get a? A was equal to
X.
r
Cos.
cos theta. Remember, it was r cos theta. So it would be 5 times the cosine of 3 pi/4. And b is going to be equal to 5 sine 3 pi/4. Well, they're helping us out. We can tell what quadrant this is going to be in. What do I mean by that? Well, this second quadrant, am I going to have a positive here or a negative? Negative. Let's go to our pi/4 finger. Which one's our pi/4 finger? Ring. Bend your ring. Flip your hand over. How many x's? Do we say ring? What is wrong with me? I'm bending my middle finger and I'm saying my ring. Okay, I'm bending my middle finger. How many x's do I have? So it's the square root of 2 over 2. Why did I do a negative? Second quadrant. And over here, it's going to be 5 times the positive square root of 2 over 2. That does not reduce, does it? So I'm just going to leave it as the negative 5 square root 2 over 2. And this would be positive 5 square root 2 over 2. And so if I wanted to write it in rectangular form, it would look like this. You'd say z equals negative 5 square root 2 over 2. Let me slide down so you can see it. Plus, because this is positive, actually, a lot of time in rectangular form, I think they put the coefficient first. Like that. So where would that be plotted? I don't know what that is as a number. 1.4, 1.7, 3.5. It's about negative 3.5. I'm going to guess negative 3.5. I'm going to say it's there. And it had the same b value as a. So that's negative 5 square root 2 over 2. Negative 5 square root 2 over 2. And that would be its point right there, like that. All right, now I have this DOL number 6 for you to try. All right, to finish this up, well, let's talk about how we can multiply and divide by complex numbers. And actually, it doesn't even, this here is complex numbers. And they don't necessarily have to be complex, but here, that's just the form. I want to show you this form as well. It looks like I might have forgotten an I here. This is supposed to have an I right there. And that part of the formula. But we have some formulas here for how to multiply or divide complex numbers. So let's apply these and finish up this packet. So first it says multiply these two complex numbers. and leave your answer in polar form. Now, these are in polar form as it is. So if we multiply, the formula is that, let me just paste it up here. I think it'll be quicker rather than, let's just go ahead and paste it. To multiply, you're going to take this formula here. And this will just help you out to know what I'm doing, so it doesn't seem like I'm pulling numbers out of nowhere. So that's the formula we're going to be using here. Is that formula. And so what I need to do is multiply my two radiuses, which in this case, it's going to be equal to 2 times, this is my radius 1 right here. That's radius 1. This is my radius 2. Radius 2, let's try that again. Radius 2, there we go. So it'll be 2 times 3 times the cosine of my two thetas, which in this case, this is theta 1. This is theta 2. Notice this is also theta 1. This is also theta 2. So I want to take my pi over 3 and add it to pi over 4. And then what I'm going to do is add it to the I sine of, again, theta 1 plus theta 2, which is pi over 3 plus pi over 4. Okay, and so let's simplify this. When I go to simplify, 2 times 3 is 6. So it'll be 6 times, and I can now, well, I'll just leave that bracket for now. Cosine of, and to add these together, I need to have a common denominator. So I want to multiply this first one by 4 over 4, and the second fraction by 3 over 3. That gives me a common denominator. So this will be 4 pi over 12. They're both over 12. 4 pi over 12 plus 3 pi over 12 is 7 pi over 12 plus I sine. Here, again, same thing. I would multiply by 4 over 4 and 3 over 3. And so once again, I'm going to have 7 pi's over 12. And that's my value right there, because it says leave it in polar form, which that is polar form. I now have a new radius of 6 and a new theta of 7 pi over 12. So if you, just to make sure you're clear on that, where r equals 6 and theta equals 7 pi over 12. That's what those values would represent. Okay, now part B, instead of multiplying, we're going to divide. And so the formula is very similar, but I'll just go ahead for the notes and capture this formula for us one more time. You can notice by formula, they are very similar, but instead of multiplying our radiuses, we're going to divide them. And then instead of adding our angles, we're subtract them. So here we go again. This is going to be R1. This is theta 1, theta 1. This is going to be theta 2, and that is R2. So if I need to divide, I would have 2/3. And then it's the cosine of theta 1, which is 9 pi over 16, minus theta 2, which is 3 pi over 8. Minus, or excuse me, plus I sine, and again, theta 1, 9 pi over 16, minus theta 2, 3 pi over 8. And so to simplify, again, like the last problem, I got a common denominator. So I'm going to multiply this by 2 over 2, which is multiplying by 1. That gets me a common denominator. So I'll have 2/3 cosine of 9 pi over 16 minus, that's going to be 6 pi over 16, is going to be 3 pi over 16 plus I sine of, again, 3 pi over 16. And that would be our solution. Now that's how you multiply and divide using complex numbers. Now we also have De Moivre's theorem. And what we're going to do on this problem is we want to evaluate what this value is. And I have a power, which means I'm multiplying this polar point times itself 4 times. And so I'm gonna use that last theorem that was given here. I'm gonna pull this last part that if I want find a value, this is what I need to work through. So let's go work this through on part. Example 10 should say part 10 or example 10. Okay, so here's what I'm given. I'm given this form right here. And so what is that going to become? I can take the radius and raise that to the power. Here's my radius. All right, here is my radius. And my n in this problem is 4. So it's going to be 2 raised to the 4th power. What I'm doing is this portion right here times the cosine of my theta here is pi over 12, but my n is 4. So it's going to be 4 times pi over 12 plus I sine of, again, 4 times pi over 12. And so I'll go to simplify this. 2 to the 4th is 16. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. That's 16. 16 times the cosine of, now this is going to be 4 pi over 12. And 4 pi over 12, if you think about it, 4 pi over 12 is the same thing as pi divided by 3. And so 4 pi over 12 once again becomes pi over 3. And let's see here, I can simplify that again. That would be 16. I'm going to evaluate here. A pi over 3 finger, that is our pointer finger, So I'm looking at the palm of my hand, pin my pointer, I flip over my hand, and I get for this cosine of pi over 3, I'm getting 1/2. That's first quadrant. Remember, pi over 3. Pi over 3 is in the first quadrant. And so what does that mean? That means my x is going to be positive and my y is going to be positive here. So it is positive 1/2 plus I, and at that same location, I have the square root of 3 over 2 for the sine. Now, when I multiply by 16, I should have my final answer here. I should have that z equals 16 times 1/2 is 8 plus, and 16, when I distribute here, 16 times I times square root of 3 over 2, it's going to be 8 square root of 3i. And now I've written it in the form z equals a plus bi. That right there is rectangular form. That is the rectangular or standard form. Like that. Okay, and I believe this leaves you. Nope, no DOL. That's it. That's a wrap.